Hello everyone, myself Viren Patel, associated with LJ Institute of Engineering and Technology. So in this current video lecture series, we are studying subject of Physics Group 1. So in previous video, we have started the chapter Laser. In this chapter, we have learned introduction and properties of laser. Now, in this video, we are covering the topics such as Einstein's theory of radiation, Einstein's coefficient, and we will derive the ratio of rate of spontaneous emission and stimulated emission. So let's start with the Einstein theory. You can see in the figure, here there are three processes: absorption, spontaneous emission and stimulated emission. So let's assume that the atomic system is in equilibrium condition. Hence, at thermal equilibrium, the number of upward transitions is equal to the number of downward transitions per unit volume. Here we know that there are three equations. In case of absorption, the rate of absorption is equal to B21 N1 into rho, where the rate of stimulated emission and spontaneous emission is B21 N2 rho and A21 into N2 respectively. Here we know that absorption process is upward transitions, but the emission process is downward transitions, because in case of absorption, the atoms comes to the higher energy level from lower energy level, where in case of emission, the atoms comes into lower energy level from higher energy level. So here we can say that absorption related to the upward transitions and emission related to the downward transitions. So here if we compare both the transitions, then the rate of absorption is equal to the rate of emission. So here B12 N1 into rho equals to A21 N2 plus B21 N2 into rho. Now, from above equation, if we rearrange the equation as B12 N1 minus B21 N2 into rho A21 into N2. Now, if we subtract rho, then rho is equals to A21 N2 upon B12 N1 minus B21 N2. Now, dividing the equation by N2, then we have rho is equals to A21 upon B12 N1 by N2 minus B21. Now, under thermal equilibrium, the number of atoms N1 and N2 in energy states E1 and E2 at a temperature capital T is given by Boltzmann distribution law. So here, the number of atoms in energy level E1 is given by N1 is equals to N0 e raised to minus E1 upon Kb into T. Similarly, atoms in energy level E2 is given by capital N2 equals to N0 e raised to minus E2 upon Kb into T, where Kb stands for Boltzmann constants and N0 stands for total number of atoms. Now, if we take the ratio of both the equations, then we have N2 by N1 equals to e raised to minus E2 upon kBt upon e raised to minus E1 upon kBt. If we rearrange the equation as N2 by N1 equals to e raised to minus bracket E2 minus E1 upon kB into T. Now, we know that E2 minus E1 is the energy difference between higher energy level and lower energy level. So we can replace E2 minus E1 as HV. So we have N2 by N1 equals to e raised to minus HV upon kV into T. So if we rearrange again that above equation, then N1 by N2 equals to e raised to HV upon kV into T. Now substitute the equation of N1 by N2 is equals to HV upon kV into T in the equation of rho. Then we have the equation of rho as rho is equals to A21 upon B12 e raised to HV upon kV into T minus D21. Now rho is equals to A21 upon B21 into 1 upon B12 upon B21 e raised to HV upon kVT minus 1. Here we have divided that equation by B21. So finally we have the equation of rho is equals to A21 upon B21 into 1 upon B12 upon B21 e raised to HV upon kVT minus 1. Now we know the Planck's black body theory of radiation. In this case, rho is equals to 8 pi h v cube upon c cube into 1 upon e raised to HV upon kVT minus 1. Now we have two equations of rho. If we compare that two equations, then we have the ratio of A21 upon B21 is equals to 8 pi h v cube upon c cube. And again, comparing the second term, we have B12 equals to B21. So here, if we consider B12 equals to B21 equals to B and A21 equals to A, then the constants A and B are known as Einstein Coefficient. Here B12 equals to B21 confirms that probability of absorption equal to probability of stimulated emission. And from equation A21 upon B21 is equal to 8 pi h v cube upon c cube, we can say that the ratio of spontaneous emission and stimulated emission is proportional to v cube. It means that probability of spontaneous emission dominates over stimulated emission. So these are the Einstein theory and Einstein coefficient. Now we can derive the ratio of stimulated emission to the spontaneous emission. So here we have the equation of both the rate of stimulated emission R21 is equals to B21 N2 into rho, where the rate of spontaneous emission R21 is equals to A21 into N2. If we taking the ratio, then we have R21 stimulated emission upon R21 spontaneous emission equals to B21 N2 rho upon A21 into N2. So here, if we cancel N2 from numerator and denominator, then we have final equation R21 stimulated upon R21 spontaneous equals to B21 rho upon A21. Now we have the equation in Einstein theory that B21 upon A21 into rho is equals to 1 upon B12 upon B21 into e raised to HV upon kVT minus 1. So replacing the right hand side of that equation, we get R21 stimulated emission upon R21 spontaneous emission equals to 1 upon e raised to HV upon kVT minus 1. So finally we have R21 spontaneous upon R21 stimulated emission equals to e raised to HV upon kVT minus 1. So this is the ratio of rate of spontaneous emission to the rate of stimulated emission. Now when the energy of incident photon is much greater than kV into T, the number of spontaneous emission far exceeds the number of stimulated emission. Hence, under this condition, HV is greater than Kb into T. Now, in order to achieve more stimulated emission, the population N2 of excited state should be much larger than the population N1 of lower state. This condition is known as population inversion. So we can say that population inversion is a process by which we can achieve the population of N2 of excited state is larger than the population of N1 in lower energy state. Now, hence in order to amplify a beam of light by stimulated emission, we have to create a population inversion state and increase the density of interacting radiation. So that's it for today's session. In this session, we have discussed the Einstein theory and we have derived the ratio of spontaneous emission and stimulated emission. Now, in next video, we will learn the basic definition, or we can say that the basic terms related to the laser, like population inversion, lasing, metastable state, pumping, and active medium. Also, we will discuss the types of pumping. So that's it for today's session. Thanks for watching.